Today, we will see how do we write radical expressions as exponents. Now, today's lesson is going to be how can you rewrite square roots, because radical, it's another way to just call roots, where you're familiar with the square roots, like square root of 4, square root of 5, the square root of 6. Know that we're going to see that today there's also different kinds of roots, but they all are being called radicals. Now, there's ways for you to rewrite a square root into an exponent, and that's what we're going to be seeing today. Roots, or radical, is just another way to just call roots. So our lesson is going to be about how can you rewrite square roots, expressions, as exponents. Because if you notice in your calculator, if you're trying to find out the value of the square root, you only have this button, which is just the square root. And there's times where the root is higher than 2. So you don't have a button for that. So first we're going to learn how do we go from square root into an expression that has an exponent. And then after that, we can put using your calculator. So let's get started. Now the main idea here, let's just read it. We can write radical expressions as exponents, because once you write into that form, then we can evaluate using the calculator. Let's get started. Now, here is an example of a radical. Oops. Why is it a radical? Because you have a root here. Now, let's evaluate the following expressions. Now, if we want to evaluate a root, we need to know how to go from this into an exponent. And that's pretty straightforward. The only thing to remember is that your root is your denominator. And you will see what I mean by this. The root is your denominator, and your exponent is your numerator. This is pretty important. This is the main idea for what we're about to do. Now, notice here that this is the little number that you have inside the root here. This is called your root. Now here, I'll only have a root of 3. So that means that my root is going to be my denominator. But my denominator, what? Well, here the base is 2. And when you go from root to exponent, your exponent is always going to be a fraction. So now here is there any exponent here? No, there's no exponent. So that means that my exponent is 1. And my root here is 3. So that means that 2, the third root of 2, I can rewrite as 2 to the 1/3. Same idea here. Let's look at example 2. The base is 2. I know that if I want to rewrite it as an exponent, I need to rewrite it. The exponent is going to be a fraction. So now here, is there any exponent around here? No, there's no exponent, so that becomes a 1. My root is 6, so that means that 6 is my denominator. So now that we have into this form, then we can use our calculator to find the value of the third root of 2. How? Well, we're not going to write it into this form because there is no third root button in your calculator. So we're just going to evaluate 2 to the 1/3. So we have 2 exponent 1/3. Now it is important that you put your exponent in a parenthesis. So now that becomes, let's just round it to the nearest 100. So now it's going to become 1.26. And now 2 to the 1/6. Now that becomes 1.12. This is pretty much the main idea here. If we're going to go from root to exponents, your exponent's always going to be written in a fraction. And every fraction has a numerator and denominator. If you see any exponent, that's going to be your numerator. in both these cases, we didn't see any exponent. We didn't see that the square root was being raised to some number. It was just a square root, so that means that my numerator is just 1. The root is your denominator, so that becomes 1/3. And then you find this using your calculator, and the same idea here. Your root is 6, so your root is your denominator. There's no exponent, so that becomes 1. 2 to the 1 6, that's 112. Let's try some more examples here. Now, let's look at example 3 here. In example 3, again, what we want to do is we want to go from square root to exponents. So the first thing I want to do is, what is the thing that we take in the root of? 5. So that's going to be my base. If you want to go from root to exponents, you know that your exponent is going to be a fraction. So now notice that here we have an exponent now. So where does my exponent go in my exponent? Root is the denominator, exponent is the numerator. Root here, it's 4, so that becomes my denominator. And now in this case, we do have an exponent of 5, so that becomes my numerator. So that means that the 4 root of 5 raised to the exponent of to the 5th, we can rewrite that as 5 exponent 5 to the 4th. And now that we have it into that form, then we can just use our calculator. Now we can rewrite that as 5 exponent 5/4, and this just becomes 7.48. Again, if we want to go from square root to exponent, your exponent, it's always going to be a fraction. And in your fraction, the root will become your denominator. In this case, my root was 4. So that means that my denominator is 4. And here my exponent was 5, so that means that my numerator is going to be 5. Once we have into that form, then we can just use our calculator. Let's bring example 4 to the top so you can kind of see any kind of pattern that you notice here. Now let's look at example 4 now. Put a calculator here. Now we need to rewrite this. We need to rewrite this expression, this radical expression, into an exponent. So what do we do now? Well, what's the base here? The base is 10. And if I want to write into an exponent, I know that my exponent is going to be a fraction. In this case, my root is 2. So the root is your denominator. So the root goes on the bottom. And my exponent is 3. And my exponent is my numerator. So that we can write the second root of 10 to the third. We can just rewrite that as 10 exponent 3/2. And then once we know the expression in exponent form, then we can just put that in our calculator. So we got 10 exponent 3/2. And now that just becomes 31.62. Now let's see, what if we want to go the other way? What if you've been given the exponential expression and you want to write that as a radical form? Now the process still remains the same, but now we're going to go backwards. Now let's say that you've been given the expression as an exponent already. So now we're still going to use the same idea here, that the root is my denominator and my exponent is my numerator. So now in these examples, we want to write the expression in radical form, or just call that root form. So we're basically going the other way. Well, the first thing I want to do is rewrite the base. The base is 7. I know that I need to write into roots. Now, again, the number that goes inside here is called my root, and I know that the root I can get from the denominator. So if we go back to here, my denominator was 2, so that means that my root is 2. My numerator is my exponent. Here it says that the exponent is 1, so we don't write that. So that's our final answer. Now let's look at example 2. Same idea here. What's your base? The base is 4, so we're going to write a 4, and we're going to write the root form of it. The root is located in the denominator. Here my denominator is 3, so that means that my root is going to be 3. And my numerator is my exponent. Here I notice that the exponent is 4. My numerator is 4, so that means that this whole thing, I need to raise it to the 4 exponent. And that's all we got to do here. So now let's look at example 3 here. In example 3, same idea. Well, I don't think we're going to need our calculator anymore. What's your base? My base is 2. You're going to write the root. Root comes from the denominator. My denominator is 3, so that means that my root is 3. I have a numerator of 5, so that means that I need to raise all this to the 5th exponent. Now lastly, let's look at examples where we have a negative exponent. Let's bring this example to the top. Now here in example 4 and example 5, we have some negative exponents, but still, we want to rewrite this in root form. But now, just like we did when we were simplified exponents, try to rewrite everything as a positive exponent. And you gotta remember that if you have something that is raised to a negative exponent, you can make it positive by switching its position. So 5x exponent negative 5/4, that's the same as 1 over 5x. Exponent positive 5/4. Again, you can go from negative exponent to positive exponent by just switching its position. We saw that on the previous video. And now that we have this form, we can just do what we were doing previously. 1 over, what's my base? 5x. We gotta put a root next to it. You gotta remember that my denominator is my root, so that here's the denominator is 4. So that means I have a 4 root. Numerator is 5, so everything needs to be raised to the 5th exponent. So lastly, let's look at example 5. Again, if you have a negative exponent, you gotta make it positive by switching its position, so that becomes 5x positive 1/2. Let's rewrite that. I don't like the way it looks like, but it's still the same. 5x exponent 1/2. All I did, I went from a negative to a positive exponent, and now that we have it to this form, the 1 remains. The denominator has an exponent of a fraction, so what's my base? My base is 5x. Now I need to write that as a root. My denominator is 2, so that means that my root is 2. Let's make that a little bit bigger. Denominator is 2, so root is 2. Exponent is 1, so we don't have to write that because it says that my exponent is 1, and we don't write that. And that's pretty much it. This is how you go from a negative, when we go from radical to an exponent, there's 2 ways that you can go. You can go from the root to the exponent, and the exponent to the root, and know that there's times where you're going to have negative exponents. And for that, you just flip it, and then you perform what we were doing under previous examples. So here's your entrance ticket. Try to write the following as an exponent.